Hey everyone, welcome back. In this episode I'm going to be working on the trim function here. So, just a brief recap, what trim is going to do is going to take this map of counts and trim off the top the indices that correspond to the largest counts in the map, while simultaneously, and in trimming the indices off, return them and also return the new counts map. And the idea is that these indices will be used to print asterisks in the right columns, and the new counts will be used for the remaining lines to print. That is the big picture, in case you kind of got lost in all this this map stuff. So what does this function need to do? Well, it takes the counts, and let's get some indices. And call a function called max indices, which is going to take my counts and return an indices. And then let's transform my counts, so I'll call this variable c's prime, and I'm going to call decrement indices i's c's. So i's is going to be a list of integers like 1, 2, and then decrement indices will take that list 1, 2 and subtract 1 from both keys 1 and 2. And then simply return them. Try compiling, not in scope. Okay, and let's get some type signatures here. Okay, so max indices, let's work on this first. So I want to filter my map and keep only the counts. And when I say count, I mean the key value pair. I want to keep the ones that correspond to the largest values, and then after that, I just want the keys. So if I have a map, here's a list representation of a map. If I have 5 zeros, 5 ones, and 1, 2, I want this function to return 0, 1, which is the keys corresponding to the largest values in counts. So this is going to be a two-step process. In order to get to here, I first need to, and this is not a type signature here, this is just kind of my mental model of what's going to happen. I first need to filter this map. Leaving only the key value pairs with the largest values, and then of course just grabbing the keys from that. So let's do this in tiny little pieces. First, I think I want to write a function called max counts, which filters the counts. So there is a filter function of map And it's just like the filter function you may be familiar with from Prelude, except it filters maps of type KA, polymorphic in both the key and value, of course. So I have some predicate that operates on the values, and a map, and I filter that map. So my predicate is going to be, A equals the maximum A in map. So this is going to be a function that takes a value and returns whether or not that value equals some max count. And then the actual map itself. Try compiling. Max count. It is a little confusing to have max counts and max count, admittedly. But this is going to just grab out the integer. Or I think I typed it as just a count. And it compiles. And I can also write this a little more cleanly using the section syntactic sugar. I think sections are pretty easy to understand, but I do think this is also the first time I've used them. But basically this is a way of applying the equals function kind of flipped, so that anything I pass to this function will appear on the left side of the equals, just like this function right here. Right? Okay, so that's what's going on there. So how am I going to get the max count out of accounts? Seems like I can use a fold here. Folds are useful for, well, folding up a data structure from some sort of thing that can be folded over or iterated over or traversed over into a single thing. So at a high level here, I'm probably going to, since I know that nothing's going to have a count below 0, it seems safe to simply fold with a seed of 0 and replace that accumulator value with a higher value as you come upon them, and by the end, when you've seen every value in the original map, you'll have the value that was most. So let's take a look at the fold functions. Let's see, fold with key, fold L prime. Let's go with fold R. So my A and B are both going to be integers here, right? Because I'm comparing integers. My accumulator is going to start off at 0, and I'm just going to use the max function. So, and then I can, of course, reduce this. Okay, so I think I'm going to stop there, but, max indices, do I need that? Oh, yes, I do. I implemented max counts first, didn't I? Okay, so, again, what we just accomplished was I can get out the counts which are maximum. So, once I have the counts which are maximum, I need to somehow grab the indices out of there. Well, the indices are simply the keys in the map. And this is nothing more than just the keys function. So my max indices function can be defined as a higher order function that does a max counts and then followed by a counts to indices. And I like how nicely this reads, because it's all in nice plain English. Max indices is simply defined by max counts followed by counts to indices. Makes perfect sense. So I suppose I should, before I cut this video off, just show you kind of what I have just accomplished. The trim function is not going to work yet because I don't have decrement indices defined, but we're almost there. And after that, I just have to implement asterisks to get Histogram to compile. Well, it compiles to get it to run and not fail. And then I will be done. But at this point, the highest level function I've implemented is max indices, and sort of orthogonal to that is the toCounts method, which I sort of glossed over. Where am I using that again? Oh yeah, that's also used in Histogram. So let's take a look. Oh, whoops. toCounts 1. Here's the key, and here's the value. Look at a few more. 3 1s, 3 1s and 2 2s, 3 1s, 2 2s, and 7 5s. Okay, that was that. That's from last time. This time we got max indices, so let's start from the bottom. Okay, so I have a map of 5 1s, 5 2s, and 4 3s. There it is. Counts to indices. That just gets me the indices themselves. Max count. That gets me the max count. Max counts. That's going to get me the actual key value pairs. There's the 1 and the 2. And then, all the way at the top, max indices. That's going to get me the 1 and the 2, which is exactly what I wanted. Alright, thank you for watching.